Okay, hello everyone. So this is day 4 of numerical masters class, and I hope you guys have solved these questions. And if you have solved these questions, please try to post your answer in the comment. Also, try to write how many questions you have attempted and how many of them was correct. Okay, so let's get started with the question number 16. So this is again a PYQ. It was asked in 1991, and this question is about finding the differential scattering cross section area. And this is talking about the scattering process. As in the earlier video also I have told about this thing, that scattering means that we have to consider the elastic collision. Also, you can see here that they have given you the sigma theta. That means they have given you the differential scattering cross section area, and they want to find out total cross section scattering cross section area. Let's get started with that. So first, let's simplify this thing. So here you can see here they have given you that kf and ki, both the magnitude are equal. Again, that they are the wave vectors, and if the magnitude are equal, we can replace this kf, which is equals to ki, equals to k simply. Now let's expand the sigma theta. Sigma theta, which is given a to the power minus b ki vector minus kf vector whole square. We can expand it by writing it ki whole square plus kf whole square plus, okay, right, minus simply minus ki dot kf cos theta. So if you put the values, it will come out to be a e to the power minus b k equals to k. So it will be k square plus k square minus 2k square cos theta. So at last we are having the result as e to the power minus 2bk square 1 minus cos theta. So this is our cross section, differential cross section area. Now I hope you know this formula, that sigma, if we have to find the total cross section area, it is equals to sigma theta 2 pi sine theta d theta. When we are solving your numericals, please keep your numerical sheet besides you so that you can understand that which formula we are applying and how it can be solved. Okay. So the integration will be from 0 to pi. Sigma theta is a e to the power minus 2b k square 1 minus cos theta, and here we are having 2 pi sine theta d theta. Now you can do one thing, you can substitute the value of 1 minus cos theta. Let's take 1 minus cos theta equals to x. So now when you differentiate it, you can simply write that sine theta d theta will be equals to dx. Similarly, when you put theta equals to 0, it will become 1. So the x key value, it will from 0 lower limit, and the higher limit will be 2. Why 2? Because at pi cos theta will become minus 1, 1 minus minus 1 plus 1, that is 2. So we can write sigma as 2 pi a. It is constant, so we can take it out from the integration, 2 pi a from 0 to 2, and this will become e to the power minus 2bk square x, and this sine theta will become dx. So now it's an easy integration of exponential. So 2 pi a, this integration will become minus 2bk square x divided by minus 2bk square, and the limit will go from 0 to 2. So you can write here like minus 2 pi a upon 2bk square, and put the limits of integration. It will be e to the power minus x is 2, so it will become 4bk square minus 1. Now we have minus sign in the beginning, so we can take it inside, so that the final answer will become pi a bk square 1 minus e to the power 4bk square. Now I want you to please interpret this thing, and if you can interpret it, please write it in the comment box, right? Although we do these exercises in the launch classes, and if you have attended the classes, please try to interpret it and write in the comment box. Okay, moving back to the next question. This question is taken from the Kepler's law, and it's again a easy question. And the question is about a body is moving in inverse square attractive field transverse a elliptical orbit with eccentricity E and time period T. So two things are given here, eccentricity E and time period T. So let's understand this thing, that according to Kepler's law, we know that from the first law, the orbit of the planets are elliptical in nature such that sun will be one of its foci. So let's say the sun is here and the planet is going to traverse on this path. Now try to understand, if this is 2a, we can call this as 2b. I hope you know that. That is semi-major axis and semi-minor axis. And if eccentricity is a, so the coordinate of this foci will be AE0. I hope this thing you know. We have to find the time taken by the body to traverse half of the orbit. Half of the orbit that is nearer to the center of force. So this is the center of the force. This AE, this is the center of the force. Let's call it as C. So half of the orbit. This is one half, like this. So this is the path taken by the planet. So what we have to do, I'm just erasing it. This is the area traveled by the planet. So we know that from the second law of Kepler, we can write that ki dA by dt, the rate of area, is always constant. So I can say that the A total, let's call A naught, which is the total area of the ellipse, which is pi AB, right? So I can say that the total area by total time period will be equals to the area swept by it by time. This we can write. So simply the time will be equals to A by A naught into T. As easy as that. This is an easy question, so I think you can try it on your own also, but let's see the result. So this A, we can write, this is the area A. This area A can be written as pi AB by 2. That is the half area. This is the complete half area of the ellipse. And from this half area of ellipse, we have to remove this triangle. This is the triangle you can understand. Now, what is the area of triangle? You know that half into base into height. What is the base? Base length is 2b, and this height length, it is AE. So AE. So just put the value here. So A will become pi AB, and we can take pi AB as common. If you take pi AB as common, here you will have half, and here you will have half, and here you're having let's say 2e by pi divided by a naught was pi AB, and this whole multiplied by capital T. So pi AB will cancel out, and the answer you will have is half into minus 2e by pi into T. So this is the result that they have asked to find out. Now this is the time period required by the planet to traverse over the center of the force when it is nearer to the central force. This is what they have asked. Now one more question they've written here, that briefly explain why comets spend 18% of its time on the half of the orbit. It simply say that if this is not a planet, it's a comet, why it only spend 18% of the time on this half. So try to understand, for comet, this is the sun, let's say, and comet do not move into the complete orbit, and if it is orbital, it is very you can say that the eccentricity of this orbital will be almost tending to 1, or it's parabolic in shape. And now if you will put t is equals to 1, e equals to 1 here, it will become minus 1 upon 2 pi into t. And when you put the numerical value here, you will get 0.1816 t, which is approximately equals to the 18% if you write in the percentage. So this is what they have asked. So for this, you must be knowing that for the comet, E tending to 1, right? So again, this was a very easy question. Last was, you can check. Okay. So if you have solved both question, please try to write if it was correct or not. Now the third question is again coming from the Coriolis force. Now these types of question UPSC used to ask in earlier days. In recent few years, we won't be finding the question like this. But from last 2 years, I'm expecting that UPSC will ask question based on the Coriolis force in the vertical motion. So there can be two types of vertical motion. One is this dropped, a ball is dropped from a certain height, and second can be when you are throwing a ball, it is going and completing the loop. So this is not our question, this is the question that they have asked now. Although if you see in your notes, we have done that also. If we throw a ball, what will be deflection? It is just throwing it. So in this question, you can understand that from a height edge, let's say this is the tower, and the height of tower to be h, right? And we are throwing a ball. Not throwing a ball, it is freely falling. Freely falling simply means that the u is 0. Initial velocity that it acquires, it is equals to 0. Now we are dropping it. And according to question, we have to find the value of x. Obviously, this x will be very small, but let's say it is going to hit here. Okay. And this deflection we have to show that two things we have to show that it is towards the east deflection, and second is the value will be 1 by 3 omega cos theta 8 h cube g 1 by 2. Now, before getting into the Coriolis force, I want to tell you a few things, and I hope you know that. The first one is the orthogonality of reference frame or the coordinates, right? Let's take 0 comma 0 here for x and y, and we know that orthogonality, I have already taught these things in class, that orthogonality of reference frame simply means that the motion of x will be independent of the y. So no matter what is the distance covered by this ball in the x direction, it will be independent of y. If this ball fall down here or here or here, whatever the x component of the distance traveled by this body, the vertical distance will be same. The time taken by the ball will be same in all these cases. And from your junior classes, I hope you know that the time it will take to reach the ground will be equals to root under 2h by g. Motion under gravity, simple concept. Now, let's add the component of Coriolis force here. So I have told you that whenever you are writing the question of Coriolis force, we have to find out A Coriolis, and which is given as 2 into V rotational cross omega. This V rotational is what? Rotational velocity with respect to the rotating frame. And I have told you this thing also, that omega, you should be writing omega cos theta j cap plus omega sin theta k cap. Also in the last video, I think in day 1 or day 2, I have explained these things, that why we take omega as this and how we are writing the east, west, north, south direction, right? So if you don't know these things, you can watch this video 1 or video 2. And the V rotational, we can write, because it is going into the downward direction, I can write it as minus gt k cap. So at any interval of time, the V will be gt. V equals to u plus at. You know that from that V will be gt at any interval of time. So what will be the A Coriolis? So let's find out the cross product of it. So it will be 2 I cap, j cap, and k cap. It will be 0, 0 minus gt, because vertical motion, I hope you remember, it is the k cap, and north, south, east, west, we are denoting by x and y. So x denotes east, west, y denotes north, south. So it will be 0 omega cos theta and omega sin theta. So from here only, you can understand that if you take I, it will be 0 and it will be gt omega cos theta and minus. So it will be 2gt, 2 is outside, 2gt omega cos theta I cap. Now from here only we can say that the deflection is in each direction because it is not minus I or j, it is I cap. So it is each direction. Now let's find out the magnitude that they have asked us to. So what will be Vx? So Vx, that is x dot. So we have to integrate this. I hope you know the integration. So the integration will come out to be 2g omega cos theta. We can take this outside and this t will become t square by 2 and plus we will have one constant c1. Now this constant will be 0 because initially I have taken the coordinate to be 0. Sorry, initial velocity to be 0. So if initial velocity is 0, c1 will be 0 at t equals to 0. And here our x dot will become simply g omega cos theta into t square. Now again, for finding the x, again we have to integrate it. So it will be g omega cos theta and this will become t cube by 3 plus c2. Now this c2 will be 0 because initial position in x is 0. Here it was 0 because initial velocity in x was 0. So from here we have x, the value. We have to find the value of x when it hits the ground. That means at time equals to t. So when you put at t equals to t, the equation will simply become g omega cos theta t cube by 3. Now put the value of t cube by 3. So it will be g omega cos theta by 3. T was nothing but 2h by g to the power 3 by 2. Now we can take g inside. If you take g inside, 1 by 3 बाहर ले लेंगे. So let's try to match with the original result. So 1 by 3 we have to find omega cos theta. So write it 1 by 3 omega cos theta. And when you take g square inside, g and g will cancel out and we'll have g left inside. So 8h cube by g to the power half. So this is the result that we are supposed to find out. So what we have done here, that this cube now we have made the cube this. So 2 ka cube 8, h ka cube h cube. And then when g will come inside, again cube, g will cancel out. So g will be in the denominator. I hope you're able to understand this thing. And this is the very important thing as far as Coriolis force is concerned. If you're able to write omega like this, and if you're able to write the v rotational in proper I, j, k, whatever the direction is, you will be able to find out any result. Okay. Coming down to the next one. Again, this question is about a body, rigid body, which is spinning with an angular velocity about an axis. So this is about an body. This is the body, and it is basically spinning about an axis. And this angular velocity is given as omega. Now, here they have given the omega is 4 radian, that is magnitude is 4 radian, and the axis is parallel to the direction of this. That means they have given you omega. So how can we find out omega? Omega is what? We have to write the magnitude and then we have to write direction. So if the axis is passing through this, we have to write its unit vector. So it will be again 4j minus 3k cap divided by 5. The magnitude of 4 and 3, that is root under 4 square plus 3 square, that is 16 plus 9, 25. So root 25 is 5. So this is the omega they have given. Now they are passing through a point A. So they are passing through a point A. This is my point A, where O is the origin in the coordinate system. So let's take, this is my O. This is my O. And A is given such that OA vector is given. So this OA vector is given as 2i plus 3j minus k. Now read the question again. A body is spinning with an angular velocity 4 radian about an axis parallel to direction of this through a point A with OA equals to this. So till now we have tried to incorporate everything which is given in the question. Where O is the origin of coordinate system. Now we have to find out the magnitude direction of the linear velocity of the body at point P with OP equals to this. So the point we have to find out, this is, let's say, P, and OP is given. Velocity of the body at point P. So point P is inside the body, which is given as 4I minus 2J plus K. And we are seeing from here, try to understand this thing. We are not at the origin, we are here from the A. So we have to find out the magnitude and the direction of this linear velocity because we are in the rotating frame. So we have to find out V inertial, try to understand this thing. So V inertial, we know that it is V rotational plus omega cross R. You might have studied this thing from the body coordinate and space coordinate also. You can use that also. That is totally fine. So V rotational will be 0 because the body is in the same point. So V rotational we can write at 0 because the body is in pure rotation. So we have to find out V inertial. So V inertial will be simply omega cross R. Now what is the value of R? So this is the radius position vector of point P with respect to A. So how can we write R? So R from the vector law of addition, you can simply write that ki R will be simply OP minus OA. And if you do OP minus OA, so 4 minus 2, 2 minus 2 minus 3 is minus 5. 1 minus 1 is become 2. It will be 2I minus 5J plus 2K. Now you have everything, just put the values, you will get the answer. So V in will be equals to I cap, J cap, and K cap. And we can write the value here. So for omega, it is I cap is 0. This J is 4 into 4 is 16 by 5. And K is minus 12 by 5. And here it is 2 minus 5 and plus 2. We can take this I cap. So for this I cap, what we can do? 32 by 5 minus minus plus and then again minus. So 32 by 5 minus 60 by 5. So 32 by 5 minus 60 by 5. Again for minus J, we can write here for minus J, this is 0. This is minus 12 into 2, that is 24 by 5 minus that is plus 24 by 5. And for K, we can understand that this is 0. So this will become minus 32 by 5. Minus 32 by 5. So you got the answer. So V inertial or V that we have to find out, it is coming out to be minus 28 by 5 I cap minus 24 J cap by 5 minus 32 5 K cap. This is the answer they have asked. Now here is a catch in this question, not catch, it's a very basic and simple point which is mentioned in the question, and examiner want you to write in this format only, that the magnitude and direction of linear velocity. So I have seen that this is the final answer, that is correct, but they have asked specifically that you have to write the magnitude and direction. So you have to solve it further and then you have to write it V, what is mod V? Again, it will be square, and if you will do this, it is coming out to be minus 0.573 I cap minus 0.492 J cap minus 0.655 K cap. Use calculator, you will be able to get that. And if you have to write the V cap, that is the direction, it is like this. Sorry, this is the V cap I have written. And if you have to find out the mod, it will be simply equals to 9.765 meter per second. So that you can write. Yes, that is the correct answer. So V in cap is minus 0.573 minus 0.492 J cap minus 0.655 K cap, and the mod will be 9.765 Fine. Okay, so this is the final answer that you have to write in the examination. Okay, let's solve the last question. And this is where you have to use 2 pages now because this is a lengthy question. So let's solve it. This question is coming from the central force motion, and again we have to use the differential orbital equation or orbital differential equation, whatever you want to say. And if you remember the formula correctly, this question is very easy to solve. Now, for the first part, if you have to find the force law, we know that this formula d square by u upon d theta square plus u is equals to minus m l square u square f of 1 by u. I want to make one disclaimer that my small u and capital U look same. ठीक है? So everywhere when I'm writing small u or capital U, both mean the same thing in the first part at least. D square u upon d theta square u minus m upon l square u square, where L is, you know that this is the angular momentum and this is the function of force. So let's convert this R into F. So R is equals to k e to the power alpha theta. So what will be u? U is nothing but 1 by R. So it will become e to the power minus alpha theta upon k. Now we have to find out du by d theta. So du by d theta will be minus alpha e to the power minus alpha theta upon k. And if you differentiate it again, d square theta, it will be simply alpha square e to the power minus alpha theta by k. This is what we can write. Now e to the power minus alpha theta upon k, it is equals to u only. This was me u. So alpha square u. If you put this thing here, you will get alpha square plus 1 u is equals to minus m upon l u square f1 by u. So from here we can get 1 upon u is equals to minus L square u cube by m alpha square plus 1. Now if you take these things as k, so f of u will become minus ku cube, where k is nothing, k is equals to this L square alpha square 1 upon m. If you want to write in r, you can simply write that minus k upon r cube. Now whenever you have these types of equation for the central force motion, you must draw diagram in the answer sheet for the interpretation part. Also, you should also talk about the relation with the R, and also you should talk about what will be the nature of the force, whether it will be attractive or repulsive, and like that. Now, from here, we have to find out the second thing is the theta t. Theta t. What will be theta t? So let's call theta t is equals to theta simply because theta will be a function of time. We know that the angular momentum in the central force motion is conserved, and we can write L is equals to m square theta dot. And theta dot is nothing but d theta by dt. So d theta by dt will be equals to L upon m r square. And we know the value of r square. So we can simply write that d theta, or let's do one thing again. R is nothing. R is k e alpha. So k square e to the power 2 alpha theta. Now we can integrate it. So e to the power 2 alpha theta e to the power 2 alpha theta into d theta will be equals to, here we are having L upon mk square and dt. So from 0 to t, and let's take at 0 the theta is theta naught, some value will be there, and theta t. Now you can integrate it. It's an again easy integration. So it will be e to the power 2 theta 2 alpha theta upon 2 alpha. So we have to integrate from theta naught to theta, and it simply becomes LT upon mk square. So we can put the limit. So it will become 2 alpha theta minus e to the power 2 alpha theta naught. Now it's a constant value. You can ignore that also. And we have 2 alpha L upon mk square into t. Now you can take this that side. So e to the power 2 alpha theta will become 2 alpha L upon mk square into t plus e to the power 2 alpha theta naught. Now we can take logarithmic both sides and we can simply find out that the theta t, which is equals to theta, if you take logarithmic, ये पूरा log में आ जाएगा and then you have to divide by 1 by 2 alpha. So it will become 1 by 2 alpha ln 2 alpha L upon mk square into t e to the power 2 alpha theta naught. So this is the value of theta we have to get. Okay, so the last part of this question, we have to find out the total energy here. Now I can say that the total energy will be 0, and without doing that, without doing the calculation, if you know how can we find that, please comment that. But before that, let's do it. So E, we know that key UR, and this U is basically my potential. UR will be what? I can write directly. So F is minus K by R square. You know that F is equals to minus du by dr. So we can simply write the value of U, that will become minus K upon 2R square. Now we have to find out the complete energy. So E in this central force motion, we know that it is equals to half mv square or r dot square plus half m r square theta dot whole square plus ur. So we have to find out r dot. Now r dot is nothing but dr by dt. We know that. And we can write this dr by dt as dr by d theta into d theta by dt. What is d theta by dt? Theta dot. And what is dr by d theta? So dr by d theta will become k into alpha e to the power alpha theta, because r is equals to k e to the power alpha theta. So you can see from here. So r is equals to k e to the power alpha theta. K e to the power alpha theta. So dr by d theta will be k alpha e to the power theta into theta. And what is d theta by dt? It is simply theta dot. So if you see here, this k e to the power alpha theta is again r. So you can write this as alpha r theta dot. Now put it here. So if you put it here, so E will become half into m alpha square r square theta dot square plus half m r square theta dot square and ur. Keep ur as it is as of now. So I can write here, this will become half into m alpha square plus 1 r square and theta dot whole square ur. Now put the value of everything. So half m alpha square plus 1 r square. What is theta dot? So I have just written this thing that L was constant and the value of L was m r square theta dot. Value of theta dot will be L upon m r square. So you can plug this value here. It will simply become L square m square n r to the power 4. Now what was the value of ur? It was minus k by 2r cube, minus k by 2r square. And what was the value of k? The value of k we have written here, this L square by m, L square by m alpha square plus 1. So put the values here. It will become half into this m and this m will cancel out. R square will become r square. So it will become alpha square plus 1 niche m r square L square. Now what is the value of k? It is L square by m. So L square by 2m r square into alpha square plus 1. You can understand both the value are same only. So it is coming out to be 0. So the total energy of this, where r is equals to k e to the power alpha theta, will become 0. So this is how we solve these questions. Now, UPSC generally do not ask question like finding out theta and total energy in recent year, but the force law is very common. If you see the past 15 or 20 years, you can find it at least 5 to 6 questions from this thing, but you should be always prepared with the theta also. Okay, so now at the last, I just want to say this thing, that if you have solved all the 5 questions and if you're able to solve all 5 correctly, please comment it. If you're not able to solve 3 questions or 2 questions, please write the number of questions that you have made it correct. Okay, so that's all for this video. Next video will be for the day 5 of week 1. Thank you everyone. Bye.